There is a lot of confusion about what cloud engineers actually do in 2026. People make it sound like you're either sitting behind a laptop typing code all day or doing something so technical that it's impossible to understand. The truth is, right now, with AI, the reality is completely different. I'm Suleiman. I've been working in tech since 2015. I started at the very bottom as an apprentice, and now I'm running multiple businesses across cloud and AI consulting, software, and my academy, where I've helped more than 900 IT professionals, engineers, and career switchers master cloud engineering and land six-figure roles, including at companies like AWS. So I've seen this career from every single angle. And as someone learning it for the very first time, as someone doing it in a corporate job, and now as someone running my own businesses in it. In this video, I'm going to show you what I actually do day to day as a cloud engineer, what the work really looks like, how much money that you can make, and the downsides of this career in 2026. Okay, so before I get into my day-to-day, let me explain what cloud computing actually is, just so we are on the same page. Instead of a company buying their own servers, putting them in a room, hiring engineers to maintain them, and guessing how much capacity that they need, they just rent computing power from companies like Amazon, Microsoft, or Google. These companies have built massive data centers all around the world filled with servers, and businesses pay to use them. You pay for what you use, just like an electricity bill. If you need more power, you scale up. If you need less, you scale down. That's cloud computing. You're renting computing capacity, networking databases over the internet. When you open Netflix, you are using AWS servers. When you scroll on Instagram, cloud infrastructure somewhere around the world is running it in the background. Virtually all applications and services that you use on a day-to-day basis on your phone or your laptop, they run on cloud platforms, and most people have no idea. Now, a cloud engineer is the person who makes all of that work for a business. You're the one who designs how a company's systems are set up in the cloud. You build it, you secure it, you make sure that it can handle the traffic, and you keep it running. If the app goes down, that's your problem. If the data gets breached, they call you. If the system can't handle Black Friday traffic spikes, you provisioned it incorrectly. But when everything runs smoothly and millions of people are using a service without even thinking about what's running underneath, that's because a cloud engineer built it right. So now let me give you the real picture of what I actually do day to day and the types of projects that I work on as a cloud engineer. We had a client, decent size, and they'd been on AWS for years. They called us because they had a production outage, and when they tried to fix it, they realized that nobody on their team actually understood how their infrastructure was set up. And this is incredibly common. It's called ClickOps debt. And here's how it happens. When a company is small, maybe a startup with 3 to 4 employees, one engineer sets up everything by clicking through the AWS console. And at that stage, it works fine because the infrastructure is simple and everything is in that one person's head. But then the company grows. More services get added, more teams start building on top of it, and nobody documents any of it because everyone's moving so fast and shipping features is the number one priority. Then the original engineer leaves, and suddenly the company has this infrastructure gap that nobody fully understands. They can't confidently change anything without risking breaking something else. We call it tribal knowledge loss because all of the understanding of how things work walks out of the door with that original engineer. That's the kind of situation that we get brought into. So we reverse engineer the entire environment. We document everything and rebuild it properly in code using Terraform so the infrastructure is version controlled and repeatable. Surprisingly, this client has been running ClickOps infrastructure for over 5 years. And now, because they started working with bigger enterprises, they had to show that their infrastructure was compliant, it was secure, and it was built the right way. Because the last thing someone wants to do is pair up with a company when their infrastructure is vulnerable. So we are brought in to fix that. Once we fixed that and we delivered great work, we were actually assigned another project in the same company. For this one, we were migrating from one region to another. This was because the original setup in the original region, specifically EU West 2, which is the London region, it wasn't set up with the right best practices. So I had to design a multi-region architecture setup and start doing a migration from one region to another. Now, another project that comes up constantly is about cost, for obvious reasons, right? When a company first moves to AWS, they are typically cautious, but they're also not sure how much capacity that they will need. So sometimes engineers pick the biggest servers just to be safe, right? Spin up environments of testing and get things running. It works. Nobody complains and everyone moves on to the next thing. But nobody then goes back to check whether the choices still make sense. 18 months later, there are servers sized for peak traffic that never actually arrived. Storage is piling up because there's no policy to clean out old data. And because AWS bills are so complex, hundreds of line items across dozens of services, nobody in the company can actually pinpoint pinpoint where the waste is. It just slowly creeps up until someone in finance flags that the monthly bill has increased significantly and nobody can explain why. So then after a long assessment, going through the entire infrastructure, the AWS account, we right-size their servers, we schedule test environments to shut down outside of normal working hours, and we set up lifecycle policies on storage. AWS themselves estimate that the average company wastes 30% or more on their cloud spend. Then there is the AI work, right? Which is the fastest growing part of what we do. And the pattern here is really interesting. Companies are watching what's happening with AI and they know that they need to adopt it. Their competitors are adopting it. Their board is asking about it. But internally, what's actually happening is that employees have already started using AI on their own, on their company laptops. They are pasting customer data into ChatGPT. They're uploading internal documents to public AI tools. They're sending proprietary code to AI systems with no controls whatsoever. And nobody in the leadership team even knows that it's happening because there's no governance or process around it. So a company comes to us and says, we need to get ahead of this and take control of this. We need our teams to be able to use AI, but we need it to be done properly. We need the data to stay private. We need to control who has access to it. We need a complete audit trail of what's going on. So a law firm wanted to use Claude to review contracts, thousands of NDAs, partnership agreements, licensing deals, and have the AI summarize it, flag risk, and also pull out key terms. But the content in those contracts are incredibly sensitive. Client names, deal values, confidential clauses. They couldn't just use a public chatbot like ChatGPT, right? So we built them a completely private AI setup using AWS with Bedrock, where the AI runs entirely within their own private environment. None of their data can leave their AWS account. We designed the networking so it's completely isolated, set the access control so the right people can access it at the right time, i.e. the legal team can use it, and configured logging so there's a full audit trail on every query. This is the kind of work that is exploding right now because enterprises are governed completely differently to the average public user of ChatGPT, and companies don't want to fall behind. And by the way, if you're serious about landing a six-figure cloud role in 2026, then simply just click the link in the description below and book a call with my team. I've had students learn cloud engineering with me and land roles across tech. Some went into DevOps, Mac went from IT help desk to AWS as a systems engineer. John had no experience and is now working at AWS in their NatSec division as a consultant. Silas switched careers at 42 and became a platform engineer. Eddie moved from a non-technical cybersecurity to hands-on cloud security role with a 72K pay rise, going way into the six figures. Dominic got hired as a cloud DevOps engineer at Siemens. So if you're very serious about landing a cloud role in 2026, then check the link in the description and book a call with my team. Okay, so we've gone over the consultancy side, but before I ran my own consulting business, I was a cloud engineer working in corporate engineering teams, and that looks a lot different. So let me explain what it was like for me. So first thing in the morning, you start with a morning stand-up, a quick 10 to 15 minute call where everyone on the team says what they're working on and whether they're stuck on anything. Now, a huge part of the job is that other teams need things from you constantly. Developers are basically your biggest customers. They'll come to you and say, hey, we're building a new feature and we need somewhere to test it, right? So cloud engineers will work with the engineering teams and they build these platforms where things can be self-served, right? So they can spin up test environments where they can try things out without affecting real users. Now, if you don't really have a mature engineering environment, then you as the engineer will spin things up for them and then tear it down when they're done. So you can configure the networking so it can communicate with the services that it needs. You can set up a database, you can make sure that security rules are right. Or a developer is trying to deploy their code and it's failing, right? The deployment pipeline doesn't work, which is the automated system that takes code from a developer's laptop, pushes it to live servers. It's throwing errors. Maybe a permission is wrong. Maybe a server doesn't have enough memory. You are the person who digs in and figures that out, unblocks the engineering team. This kind of work is constant. There is always someone who needs something from the cloud engineer. Then there is access and permissions. Now, this sounds quite boring, but it actually matters a lot, right? Every person and every automated service in your cloud environment has permissions that control what they can and can't do. When a new person joins the company, they need access to certain systems, but not others. A junior developer shouldn't have the same level of access as a lead architect. When a developer needs to debug something in production, the live system that real customers are using, they might need temporarily elevated access. Your job is to grant it in a way that's tracked, time limited, and automatically revoked when they are done. Because if that elevated access stays active and someone accidentally deletes something in production, that can become a real incident. And when a compliance audit comes around, you need to show that every account, every role, every permission is justified and documented. If an auditor finds a gap, then that can result in fines. So it's not glamorous work, but it is the kind of thing that keeps the company out of trouble. One thing that genuinely surprised me early on is how much time that you spend talking to non-technical people. Product managers who want to understand what a new feature is going to cost in terms of infrastructure. Finance wants to know why the cloud bill went up 20% this quarter and they need you to explain it. VP wants to know why a migration is going to take 6 months and whether you can make it happen faster. Being able to take something so deeply technical and then explain it clearly to someone who doesn't have the same background is one of the most underrated skills in this career. The culture varies massively depending on where you work. Some companies have heavy process, formal change management boards, approval workflows for everything. Others are more agile, where small teams move fast with a lot more autonomy. Both teach you completely different things. The structured environments teach you discipline, risk assessment, and how to operate in high-stakes systems where a mistake can affect millions of people. The agile ones teach you speed, ownership, and how to make decisions when you don't have the perfect picture. And I'll be honest, there are slow days as well. Days where you're just waiting on approval, sitting through meetings that could have been a few Slack messages. I mean, that's any corporate job, right? But when you have a full migration, a new architecture design from scratch, a security overhaul, those are the periods where you learn the most and the work is genuinely engaging. Work-life balance is pretty solid, to be honest. Sometimes you have to be on call or rotation, but typically now in mature engineering environments, that's done by the SRE teams in case something breaks outside of work hours, but it's manageable. The biggest value of working in corporate is the exposure to real scale and actual consequences. So you're not working in a sandboxed environment or doing a little tutorial from YouTube or Udemy, right? You're operating systems that serve thousands, if not millions of users. I've worked on platforms that literally serve hundreds of millions of customers for Fortune 500 companies. And as a byproduct, you learn how systems actually behave under load. You understand how real engineering teams coordinate during an outage when the pressure is on. That experience is something that shapes your career as an engineer and it can't be faked. In terms of career paths, this is probably one of the biggest advantages of cloud engineering because you are not boxed into one job title. The architecture skills, the system design, the networking, the security, the DevOps, the automation, building reliable systems at scale. They are the same skills needed for some of the most in-demand roles in the entire tech industry. DevOps engineer, platform engineer, site reliability engineer, solutions architect, cloud security engineer, systems engineer, infrastructure engineer. These are all roles that cloud engineering skills directly qualify you for. Now, companies do use these titles differently, sometimes interchangeably, but they all draw from the same core knowledge. Now, in terms of salaries, cloud engineers are some of the best paid in tech. The average salary is around $150K in the US, with senior cloud engineers and architects earning above $200,000. I've seen roles at companies like Apple at over $380,000 for a cloud engineer. And don't forget, you could also apply for other domains like DevOps, SRE. So yes, the compensation is great if you have the skills. And the reason the salaries are high is very straightforward. The demand massively outstrips the supply. AWS has reported a global shortage of 6 million cloud professionals. Big tech is spending over $700 billion in 2026 on AI and cloud infrastructure, which means the demand is for cloud engineers who are talented but can also solve real problems. Now, I also want to be very real about the things that aren't as glamorous because no career is perfect. You need to be comfortable with ambiguity. Now, unlike following a tutorial with every step is laid out for you, real cloud engineering involves figuring things out. The client doesn't always know exactly what they want. The documentation doesn't always have the answer. You have to be the person who can work through uncertainty and find a solution. If that sounds stressful, I get it. But honestly, that's what makes the work so engaging. Every problem is a puzzle, and there's constant change. But I think this is the standard now. AWS releases new services and updates existing ones regularly. The AI landscape is changing weekly. You have to enjoy learning because this isn't a career where you learn a thing once and then coast for 5 years. But if you are someone who gets bored doing the same thing every single day, cloud engineering is genuinely one of the best careers that you can choose because it's always evolving. So if you're considering becoming a cloud engineer, whether you've got no experience coming from a non-technical background or you're an existing IT professional or engineer, there's plenty of options for you in the cloud. You've seen in this video the kind of problems that companies are dealing with right now, and these aren't going away. If anything, they're getting worse as more companies start to adopt AI. The engineers who can walk into those situations and actually solve them are the ones who will never struggle to find work. There's always room for the best, right? So focus on solving real problems, tie everything back to business impact, and build the kind of skills that companies can't ignore. As always, I'm rooting for you. Good luck.